This video shows you how to convert from a denary number into a binary number. A denary number system is also known as the decimal number system, and for Eduqas and WJEC GCSE students, there's a small number that is placed next to a value to represent its base. The number 173 has a 10 next to it because denary is base 10 as it uses 10 values, 0 up to 9. We're going to convert 173 into binary using 8 bits, which is standard for a GCSE or A-level question. I've started by writing out 1 on the right and doubling each time until I have 8 values, for the 8 bits required. You'll recognize these numbers if you have previously converted from binary to denary. I've written my denary number, 173, clearly on the side of the page. Starting from the left with the MSB, which is the most significant bit, which in an 8-bit number is 128, I check to see if it fits into my denary number. If it does fit, I write 1. If it doesn't go into the number because it's too large, I write 0. So 128 does go into 173, so I write 1 beneath the 128. When you write a 1 beneath a number, you have to take that number away from your denary value. Otherwise, 128 or any number larger than that would all be 8 ones, which couldn't be possible as every denary number must have a unique equivalent. So because I've written a 1 underneath the 128, I have to take that away from my denary number of 173, which gives me 45, and I've carefully tracked that on the side of my page. Now I move on to the next number, which is 64, and I compare that to 45. 64 does not go into 45 as it is too large, so I write 0. Nothing has changed, so I'm still referring to 45 as I look at the next number, which is 32, and 32 does fit inside 45. So I write 1 underneath the 32, and now I need to take it away from 45. This makes my new denary number 13. Now I look at the next number, which is 16. 16 does not fit into 13, so I write a 0 beneath it. The next number to look at is 8. 8 does fit inside 13, so I write 1 beneath it. Taking 8 away from 13 gives my new number of 5. When it gets to smaller numbers like this, you might be able to spot that 5 is going to be 4 and 1, but I'm still going to continue step by step. 4 goes into 5, so I write 1 beneath 4. Taking 4 from 5 gives just 1 remaining, and now I look at 2. 2 does not fit inside 1, so it's a 0 to place beneath the number 2. Next I compare 1 with 1. 1 fits perfectly into 1, so I place a 1 beneath it. Taking 1 from 1 obviously gives 0, and when you've got to 0, you know that the number from then on will all be zeros, but we're at the least significant bit, the LSB, anyway, and we're at the end of our number. Writing out the final answer next to the original question, you can see that 173 is equal to 10101101. I've put the 10 for denary after 173 and the 2 for binary after the binary number. It's 2 because binary is base 2. It's just got 2 possible digits, 0 and 1. Test your understanding of converting from denary into binary by taking the self-marking quiz, which you can find in the description to this video and on the CS Noobs relevant pages. Once you have answered all 8 questions, you'll get your score and you'll be able to see feedback on any questions that you didn't get right.